Hello, I'm Taylor Howard. Today, you've seen me. No, not really. That's an alias, okay? Really, I'm Grandmaster C. You've seen me in such fine quality chemistry epic videos as Stoichiometry Part 1, The Mole is the Foundation, and Grams to Moles and Rolls to Grams, How Do I Decide? So today what we're going to do, we're going to look at another tool that is used in stoichiometry calculations, and then it deals with the ratio of moles to moles. You've done moles to grams, grams to moles, and you figured out how many grams there were in a mole of something using the periodic chart. So those are three tools that you guys have, how many grams there are in a mole. If we're going from, I have so many grams of this, how many moles do I have? And I have got this many moles of this. How many grams is that? So you got those three tools, but you need another one. And you're just about ready to do some serious stoichiometry because we're covering the tools. So here we go. We have here, if you have only 5 moles of H2 and excess O2, how many moles of water are going to be made according to this chemical equation, this chemical reaction? Now, first thing you always want to make sure is that your reaction is balanced. Don't worry, for the purposes of this fine quality chemistry educational video, they're balanced. Okay? So when we look at something like this, okay, there's some pieces of information that we're going to need. We know that there's O2 plus 2H2 gets us 2H2O, so that means there's a ratio that's there. And that ratio is 1 to 2 to 2. Okay? Now remember that we are looking at our coefficients here. Those are the coefficients that we need to look at because that's what we're going to know about the mole-to-mole ratios. Okay? Now, here they give us the information right here. Remember, part of problem solving is looking at what are the pieces of important information that you need. Well, I got 5 moles of H2. Okay, so I have 5 moles. Great. And excess O2. Ooh, hey. Excess O2, what does that mean? Well, that basically means we're going to run out of the 5 moles of hydrogen gas before we run out of oxygen. So if you're looking in the real world, if you're in an industry and you're manufacturing something, that's the excess probably would be your cheapest ingredient, because what you are going to have a limit as to how much material are you going to be able to manufacture, how much ammonia are you going to be able to manufacture, for example. So it's excess O2, so I'm going to go ahead and write EXC underneath the O2. And they're asking me how many moles of water am I going to make doing this. Now, notice I said moles to moles. This is a mole-to-mole calculation. And you may notice here, 2H2, for every 2 of these H2s, we get 2 of these H2Os. Okay, now, do I have to worry, before this problem, do I have to worry about the oxygen? No. How come? Excess. If it's excess, I have more than enough to take care of it. So if it makes you feel better, you can sit there and cross that out. Doesn't that make you feel good that you can cross that out? It means you have the power to do that. Yeah. Okay, we're going to show this. So now let's take a look at this. Well, we know that there's got to be a certain ratio that's involved here. There's a ratio and there is a proportion. Oh. What do you mean? Well, let's look at this. If I have my ratio here of 2H2 to 2H2O, that's going to equal, well, they're giving me 5 of these H2s. How many of these H2Os am I going to get? Ah, okay. Now, is there another way to set this problem up? There is. Because you will get the same thing. You can do it 2H2 over 5H2 is equal to, okay, 2H2O over however many H2O. Now these are two ways that you can set it up. They're both proportions and they can be set up equally well. And you will come up with the same answer. Because then the next thing, now that we have all this in place, we can go ahead and cross multiply. We can cross multiply and divide. Now, here's the kicker, boys and girls. It doesn't matter which way you set it up, as long as, and that's the key, that whatever is the original ratio, the 2 to 2, okay, which we got from our original equation here, we're going to make sure that you guys have it set up where you're consistent. Okay, notice the red and the blue arrows forming across. That's because of the cross multiply. Cross, multiply, divide. That's it. Now let's try that one more time. Cross, multiply, divide. Exactly. Like that. So, let's go ahead, and if you notice, if you take a look at the cross multiply divide, you're going to find it doesn't matter which way it's set up. It's going to come out the same. That's the beauty of it. So let's go with it. So I'm going to take the blue here. Doesn't matter which one. So it's going to be 2 times x is equal to 5 times 2. Okay? Now let's work through the math. Okay? So I know that 2x is equal to 10. Let's just continue working it out here. I am now going to divide both sides by 2. Why do I do that? Because I want to get x by itself, because that's the goal. I need to know how many moles of water am I going to get out of this whole thing. Now I end up getting x is equal to 5 moles of water. Yay! Yeah, exactly. That's it. And you're going, wow, didn't we do something like this in another video? Yup. You might want to think about Chapter 11 dealing with the gas laws when we were changing the pressure units, like from atmosphere to PSI, and we had to use the vamos a la playa, oh, oh. Yeah, you might remember that. Same idea here. It's a proportion that we're going through. Okay, let's go to the next one. The next one here, now we're in the business of making ammonia, which we can turn around and sell it to fertilizer companies, but we can also sell it to household cleaner companies, but it can also be used in explosives. So there can be, remember, chemistry itself is not good or bad. It can be used for good, but it can also be used for evil. And how do you make that determination? God's Word. Really simple. Okay, so how many moles of ammonia, NH3, can be made from 5 moles of N2 and excess H2? Okay, so here's our excess. And again, excess, that means we have way, TMS, too much stuff. Okay? Now the N2, they gave us 5 moles of that, but we need to know how many moles of NH3 are we going to get with this. Okay, fine. Not a biggie. So, I got the power! I can cross that out. Ooh, that should make you feel good. Because you got the power to cross that out, you can ignore it. Now, is there a point where you cannot ignore it? Yes. We'll deal with that later in another video. Okay, so here we go. I know my ratio. Now I can set it up both ways again to show you guys it's totally legit. I know I have 1 and 2. Where did I get the 1? Right here. You say, but there's no 1 here. Right. In a chemistry equation, they're not going to put the 1 before it because they're assuming that if you see this by itself and there's no coefficient there, then that means you have 1. Okay, just a quick, friendly reminder. Okay, so I have 1 N2 over 2 NH3 is equal to, well, I have 5 moles of N2, excuse me, over how many moles of NH3? Okay? So that's one way we can do this. We can still do it another way where we have 1N2 over 5 moles of N2. Now you're saying, well, wait a minute. Don't you need to write the word moles up here? No, I don't. If you want, you could, to help on how you see things. But remember, you want to make sure that you keep your stuff on the level, okay? Look at the equation and look how I'm writing it in, okay? And we have how many moles of NH3? So again, we can go ahead. It doesn't matter which one you use. We can still cross multiply and divide. Again, we can still do that. Okay? So I'm going to use this one here. So I know that 1 times x is equal to 2 times 5. So x has to equal 10 moles of NH3. And that's it. You'd say, wait a minute, you just used this one here. What about the other equation? Because I set the equation the other way. Okay, 5 times 2 is 10 is equal to 1 times x. X equals 10. Who brought the boom? See, it doesn't matter which way as long as you pay attention to how you're setting it up, because it is easy to mess that up. All right, let's move on to the next one. If you only have half a mole, now you'd say, wait a minute, your English is off. I know, just work with it. So half a mole of NH3 and excess O2, how many moles of NO are being made? Now notice this is a more involved chemical equation. Here we've got ammonia gas, combining it with oxygen, we're igniting it, we're burning it. Okay, so that means we'll get a lot of nitrogen monoxide, if you will. And here we got water in the form of a gas. So we're going to get water vapor out of this deal. So, what does this look like? Let's see, it says excess O2, so here's our excess, and here we have 0.5 moles here, and they're asking us how many moles here, and that's it. Now, here's the thing. Well, what about the water? The water is part of the equation, right, but they're not asking you about the water, and that is probably because they don't care. In the industry, when they go manufacture something like this, the water, since they're not interested in it, okay, it's going to escape out into the sky through through some exhaust vent. No big deal. Okay, so we can turn around and we can cross out the water. That's great. And we have the O2 that we can also cross out because it's an excess. Whew. I just cut down a bunch of the work, huh? You kind of freaked out about that water thing there for a moment. I know you did. But that's okay. Relax. It's gone. And this is gone. So this is what we have left. This is not going to look too bad, guys, because here we go. 4NH3 over 4NO is equal to 0.5 NH3 over X NO. Okay, that's one way for us to look at it. Let's go ahead, let's look at it another way where we have 4NH3 over 0.5 NH3 is equal to 4NO over XNO. Okay? And one more time, you can go ahead cross multiply and divide. The exact same thing. Wow. Okay? So again, it doesn't matter which one I take, so I'm going to go ahead. So 4 times x, 4x is equal to 4 times 0.5. Or 4x is equal to 2. Let's keep working it. So 4x divided by 4 is equal to 2 divided by 4. The 4's cancel out. As a result, as I bring the arrow for our final thing, x is going to equal 0.5 moles of no. This is our final answer. That's it. That's all you need to know about mole-to-mole calculation. You'd say, but wait a minute, that's all for the excess reactant, right? Yeah. But what about things that have a limited reactant? That involves other things, okay? But for now, you have got the third basic tool, well, I should say the fourth basic tool. You figured out what's a mole and how many grams in a mole that there is from previous videos. You got to be able to change from grams to moles in another video, from moles to grams in yet another video, and here, moles to moles in another video. Hey, I hope that this helped you guys out. And that's the end of this video here. But again, I showed you guys, I went step by step, showing you the calculations. Again, go back, rewatch, okay, for 3 different examples. Hey, I'll catch you guys the next time around. Hasta.